There was a question last night about the homework. So let's go ahead and look at number 5. We just need to interpret this graphically. So we're going to do x to the third. That's not working. X to the third plus 2x squared minus 3x plus 4. I should put all that in parentheses just so when I divide, I make sure that it's all being divided by what I'm trying to divide by. Just a division symbol. Now I see it all went to the top, and then that's over x squared plus 2x minus 15. So now when I look at this graph, I'm going to even zoom out on it a little bit. You can clearly see what happens. It comes up from the left up to here, drops back down. We have an asymptote here, comes down from the top, crosses somewhere in there, crosses again. If we zoom back in, we can see where it's, oh, it doesn't cross a second time. It fooled me. I can see that it crosses at negative 3.284, but it's never going to cross the x again. So that's our only answer, is at negative 3.284, because that's where it crosses the x-axis. So that's it. Because that's within our interval from negative 10 to infinity, we know that it's all good. Make sense? Good. If we look at number 11, first thing I have to do is subtract the 7 over to the other side, right? So when I subtract that over to the other side, that gives me 5z squared plus 6z minus 7. All right? So now let's just use the quadratic formula. So that's negative b, so negative 6 plus or minus the square root of b squared, which is 6 squared, minus 4 times a, that's 5, times c, which is negative 7. And that's all over 2 times 5. So then that leaves me with negative 6 plus or minus the square root of 36. The negative 4 times 5 is negative 20. Negative 20 times negative 7 is a positive 140 over 10. 36 plus 140 inside of here gives me 176. So I have negative 6 plus or minus the square root of 176 over 10. 176 is not a perfect root. I'm sure I could break it down. Probably not going to make you do that. So you can just leave it in this form. Number 12, I'll let you try to do that one on your own for homework tonight. One of the ones that I did want to go over was number 14. Number 14, it says to factor, we had x to the 6th. In general, we've only seen x to the x squared being factored. But if I look at that middle term is x to the 3rd. So since that's x to the 3rd, that tells me that if I'm looking at this, if the middle term is x to the 3rd, normally that would be something like, this would look like something like x squared minus 4x plus 4, like that. So our middle term gets squared. If I square 3, or square x to the 3rd, that's going to give me x to the 6th, which tells me that this is just x to the 3rd, and this is x to the 3rd. And that's how I would end up with x to the 6th. And what multiplies to give me positive 4 and adds to give me negative 4? That would be negative 2 and negative 2. Now these are the same exact thing, so I only have to solve one of them. So this becomes x cubed minus 2 equals 0. Add the 2 over, gives you x cubed equals 2. Then take the third root, or the cubic root of both sides, and I get x equals the cubic root of 2. And that's it. Yes, sir. Okay. This over here, this part, was just showing you that if I took my middle term, the x to the third, and square it, that would give me x to the sixth, which means that both of these have to be x to the third. This one and this one. And since there's no coefficient, it's just a 1. Then looking at your last term, that's what you check next. Looking at your last term, before, what multiplies to give me 4 and adds to give me negative 4. So I need to look for factors of 4. 2 and 2 are factors. 4 and 1 are factors, because 1 times 4 is 4, 2 times 2 is 4. But if I do 2 plus 2, that's not a negative 4. I also have negative 2 times negative 2 would give me 4. Negative 2 minus 2 gives me negative 4. So I know that these have to be negative 2 and negative 2. So it really just comes back to factoring. Don't let this x to the sixth complicate it. If you see one that's x to the sixth or anything higher than x squared, especially in this chapter, it's got to be coming back to this middle term squared. We'll give you this one. All right. When it says find the number of real solutions of an equation, it's important to put it back in our ax squared plus bx plus c form. We have to get this 31x back over to the other side. So it's going to give me 20x squared minus 31x plus 12 equals 0. Now, if it wants to know the number of real solutions, you don't have to actually solve for x. What you actually have to do is take the discriminant. B squared minus 4ac. If you remember correctly, that's just the part that's under the square root from the quadratic formula. So now we're just plugging numbers in. Negative 31 squared minus 4 times 20 times 12. I take the square root of that. Actually, I don't even have to take the square root of it. When I put all this together, negative 31 squared, everybody knows is, nobody actually knows what that is. Mental, scientific. So I do negative 31 squared minus 4 times, it was 20, right? Times 20 times 12. Wow. I was not expecting that to turn out so good. That gave us 1. All right, if this number that we get is a positive number, so all this equals 1. If that's a positive number, then you know you have 2 real solutions. If we solved this and we would have come up with 0, like if this would have been equal to 0, that tells you that it's 1 real solution. And if we had got a negative number, that tells you there's no solution. So that's all you have to do for this. I was clapping for myself. I felt proud. All right, that's enough of giving you answers to your homework. Yeah, practically gave you the whole thing. No, no more. I know. All right. Isn't this the one we just did? It is. So boom, we don't have to do that one now. Number 28 is on your homework, so you're not tricking me into doing that one. Just remember, we're going to do one example of these. Just remember, well, we'll do 2 actually. If I'm looking at the first one, I'm going to do number 30. Absolute value of x minus 5 equals 3. So now I have to get rid of my absolute value. Whenever I do that, it creates 2 separate problems. X minus 5 equals 3. X minus 5 equals negative 3. And then just solve for x. X equals 8. And x equals 2. Done. Any other questions on that one? We good? If I look at one like number 32, that's not as fun. That's because we have variables on both sides. So if I look at 32, I'm still going to make that 2x minus 1 equals x plus 4. And then 2x minus 1 equals, make sure you put the negative out in front of everything so that I remember to distribute that. Solve the left equation, subtract the x over. That's going to give us x minus 1 equals 4. Add the 1 over, x equals 5. On the right equation, 2x minus 1 equals negative x minus 4. Add that x over, gives me 3x minus 1 equals negative 4. Add the 1 over, 3x equals negative 3. So x equals negative 1. I know I said I was going to do 2 on this one, but let's move on to another one. Look at number 33. If you look at 33, it looks different than the rest of the ones on this page, right? So when we look at this one, we have to realize that it's got to be a positive number under the root. So that's really an absolute value question. Because this would have to be a positive number. In general, you're just going to break it down, factor it out. What multiplies to give you x squared? It's going to be x and x. So that'll give you the first number out here. Then what multiplies to give you -2 and adds to -1? What multiplies to give you -2 and adds to -1? -2 and +1. Set each one of those equal to 0. It gives me x equals 2 and x equals -1. Now I'm going to pull up Desmos again here, just for fun. I'm going to put this in. SQRT of x squared minus x minus 2. There's my answers. So even though I said solve for x, you could be putting each one of these into Desmos and checking your answers. Which means when you have the chapter test on Monday and you have like 24 hours plus to do it, there's literally no reason why you wouldn't go to Desmos to check your answers. If you just give me -1 and 2, that's really going to hurt your grade, because if I don't see the work, I'm going to give you about a third of the credit that you should get on it for a correct answer. So if I'm telling you to solve for x, or say solve algebraically, and you just give me these answers, you're going to get some points, but not much, without the work. Use this as a way to check. That's my public service announcement. Whenever you're doing the square root sign in Desmos, SQRT. Additionally, you see down here there's a little keyboard. If you click on that, it'll bring up a keypad that you could just click it. It doesn't look like there's a limit here. That's crazy. All right. Forget everything you just did. Forget everything I've ever taught you. I forgot to do the most important step first, which would be to subtract this over to the other side. So that now I have the square root of x plus 1 equals 1 minus the square root of x minus 1. Now I square both sides right away. It gives me x plus 1. Just cancels this out. Equals. Now when I square this side, it's going to get a little uglier here. Because remember, that's like 1 minus the square root of x minus 1 times 1 minus the square root of x minus 1. So we got to FOIL this. So first should be 1 times 1. That's just 1. Outer is 1 times negative root x minus 1. Inner is the same thing. So that's going to be minus 2 root x minus 1. And then last is multiplying this by this, which is going to get rid of our root. And that's going to make that plus x minus 1. Now we can simplify the right-hand side. Left I'm going to leave as x plus 1 for now. This 1 minus 1 cancels those out. So I'm left with 2 times the square root of x minus 1 plus x. I'm going to subtract my x to the other side. I'm now trying to get this root by itself. That's 1 equals 2 times the square root of x minus 1. Divide by 2. Gives me 1/2 equals the square root of x minus 1. Get rid of my square root. I square both sides. It gives me 1 squared is 1, 2 squared is 4. So it's 1/4 equals x minus 1. Add the 1 over to the other side. And that gives me 5/4 equals x. That's better. That is 100% the correct answer. Don't ever